Today we're going to be exploring materials and making ooze, which is quite exciting, but you might need some help with an adult. So make sure you have an adult present to help you with the mixing, okay? Next up, we're going to go through the materials. The first thing you need is a gallon Ziploc bag with 1 cup of cornstarch. You also need a spare gallon Ziploc bag with nothing in it. You need 1 Ziploc bag that's sandwich size with nothing in it. You're going to have a measuring cup full of ½ cup of water. You're going to have however much of whatever food coloring you like, probably a few drops. And then we're going to have 2 raw eggs. So first up in our experiment making, we're going to take the bag that has our cornstarch in it. We're going to have it open and ready to pour liquid in it. So we take our food coloring, we add just a few drops to dye whatever color you like, and then you can just shake it up. My favorite color is green, so we're going with green today. Okay, next up, we take the food coloring water, and we're just going to pour a little by little into our cornstarch bag. So you pour a little bit in, and then holding the bag, and normally you're going to get a parent to help you, okay? Then we just mix it together, the cornstarch and the water, just to help it dissolve a bit. And then we gradually add more of our water with our coloring. So add a little bit more, mix a little bit more. We're trying to break all these lumps up. Okay, so it's still a little dry, you can see. We've got some big lumps. Some of it's a little liquidy, some of it's a little thick. And we're just gonna pour the remaining of our water in our dye. So once we're done with that, we're going to seal up our Ziploc bag with a bit of air, okay? This will help you be able to mix it better. So we're just gonna mix away and break up all of that cornstarch, okay? It's gonna slide all around, and you can lay it down on the table and mix it up. You wanna make sure you dissolve all of the cornstarch. So the goal of this ooze is it's going to take a unique and special property where it's going to change from a liquid to be a solid form. And so it's going to be both of those things, not simultaneously, but it's going to go from a liquid to a solid when there's a direct force on it. So you just want to squeeze and make sure all of those clumps are well dissolved. So once you have it dissolved, like I have it, you see how it's running, but it's not quite forming a solid mass when you squeeze it? So it needs to thicken a little bit, okay? So what we do is just set it aside and come back to it in a few minutes, and then it will be the right consistency. Now for the sake of time, we have a bag already prepared, so I'll show you what it actually will look like. So this is our ooze, okay? It's thicker, as you can tell when I squeeze it, but it's also a liquid and pours when I turn it on the side. So this is the exact property that we're aiming for, okay? A liquid that pours, but also nice and thick as a solid when forced upon. Now, time for the exciting part. What we're going to do is the experiment, okay? So what we do is take a Ziploc bag that's a sandwich. We're going to put 1 egg in it. This is a raw egg, remember? I want you to try to squeeze out as much air out of the bag as possible without breaking the egg. And then we're going to carefully open up our ooze bag and put the bag with the egg inside. Now try to squeeze out as much air, once again, from your ooze bag and zip up the Ziploc bag. Next up, you take your spare empty gallon-sized bag and you put your egg in it. Okay? From there, we zip that up. We try to get all the air out of the bag. And then we have a raw egg in 1 bag. And then we have a raw egg in a bag in the ooze bag. Now, what happens with the raw egg? It cracks sometimes, and it can break if you're not careful. And that's exactly what we're aiming for today. We're going to see what happens to these eggs when we drop it at a height. So if you might need some help with the parent, that's fine if you can't reach, but try to put the bags up both together at the same height, and then you're going to drop it, okay? 1, 2, 3. Let's see what happens. So The bag with just the egg, you can tell, has cracked. It had nothing to protect it, and it's cracked and split, and now you can't utilize your egg anymore. Let's see what happened with this egg. So, in this bag, with the ooze, you can tell that it hasn't cracked, that the egg is still intact. And why is that? So what exactly is going on? Well, the ooze protects the egg. And this happens because when dropped at a height, there's a force that acts upon the ooze. And when that happens, cornstarch forms clumps and hardens. And when it hardens, it takes the impact of the drop down force and becomes a solid and then protects the egg. However, right afterwards, it goes back to being in its liquid form. So that has a special property, which is the non-Newtonian property, where it changes from a liquid to a solid when there's a force. There's similar technologies that researchers have been working on, which are shear thickening fluids, and these can actually be implemented into various fabrics and garments. Some examples of that could actually be protective armor. So you can actually have this armor with the shear thickening liquids, and then you can be all flexible and moving around, and then if you were struck really quickly by a force, it would solidify and harden up, and with that you can be protected. Now, how exactly is that nano? Well, when something is at the microscopic scale, you can be able to manipulate it and see how it is affected at the nanoscopic scale. But what exactly is nano? Well, when you have a meter stick, it's so long, but within 1 meter stick is actually 1 billion nanometers. It's extremely small and you can't see it with your human eye, which is exactly how nanotechnology is. You cannot see it with your human eye, but scientists can actually observe what's happening at the nanoscopic scale and see how those behaviors at the nanoscale can change the materials and properties of various materials. So with that, researchers can actually enhance nanotechnology and make new applications by working at the nanoscale. An example of that are those new fabrics that have actually implemented nanomaterials just like the ooze. So with that, this new material exhibits their non-Newtonian property, just like the ooze, and with that, you can make those cool armors that protect you, or you can actually just have common things that you wear every day, like hats. So I hope you get to make this ooze at home, and you get to try, crack some eggs, and see what happens. I sure hope you enjoyed watching this video. Thank you so much. This experiment was brought to you by the Center for Materials Research at Norfolk State University and the Children's Museum of Virginia. Thank you.